All right, ladies and gentlemen, dimensional analysis is literally a way that we can convert easily and efficiently from one unit to another. Today's conversions, as you will see, are really not that hard. You probably would be able to do them without this method. The reason we start with easy conversions is so that you can get the method down well, and then we can move on to more advanced conversions at which this format, dimensional analysis, excels. Okay? So, what I want you to do today is I want you to be taking notes on your packet. The blue sheets, by the way, please listen carefully, if in pristine condition, can be used on a test. You cannot write on them, do not fold them, crinkle them, rip, tear, or stain them. If they are in pristine condition, you may use them on a test. The only thing you may have on there is your name. Okay, the blue sheet. I've color-coded them on purpose. Okay, so the blue sheet, and any blue sheets you get in the future may be used, and you'll find to be very helpful. Yes?
Should we put our homework in today?
Not yet. Okay? Okay, so dimensional analysis. As far as homework goes, I'll collect your homework probably tomorrow, okay? Because we need to go through this, and this is going to take quite a bit of time today. All right, the first thing you need to do right here on the front page, okay, is I want you to go ahead and create what looks to be like a chart, okay? So it's going to look something like this. All right, this is an intro activity to help you get the method down that we're using. Okay, I want you to think of this as something that helps you organize multiplying fractions. Okay, think about it in terms of multiplying fractions. So let's say I do the following. Let's say that I do, or I insert the following fractions. 4 over 1, 3 over 2, 1 over 7, x over a, and a over x. Okay, so put all of these in on that very first page. Now, when you look at a variable like x or a, please understand it's just a placeholder. Anything can be a variable. Anything. Could be a chunk of cheese, okay? It could be a smiley face. It could be anything. Just because we use letters, letters are simple because we're used to them. All right, but I, for instance, could change this x to a chunk of cheese. So I'll even do that. I want to emphasize this point. If you want. Okay. So they could look like pi, whatever, they're a little off. But what you should notice is that anything can be a variable. Variables are placeholders. They represent something else. Okay? They represent something else. However, they are still subject to all the rules and all the regulations of regular mathematics. Okay? So, before I go anywhere, is there any simplifying I can do? Anything that's in the top and in the bottom that I can kind of work out already? Yeah.
4 and 2.
Okay, 4 and 2. All right, 4. Remember, these are fractions. 4 over 1, 3 halves, 1/7, cheese over a over cheese. Okay, these are literally fractions, proportions, and I'm multiplying them. Okay, so I'm even going to put a little dot that represents multiplication in the middle here. So you know we're literally multiplying fractions is all we're doing. And when you multiply fractions, you can simplify things that are both in the numerator and the denominator, like 4 and 2. 2 goes into 4 2 times. 2 goes into 2 one time. So that 4 is going to change to a what? 2. And that 2 is going to change to a 1. Is there anything else that can be simplified? Anything that's both in the top and the bottom that can be gotten rid of? Grace? Oh, we're going to work on multiplying cheese. It's going to be the cheesiest thing you've ever seen. Okay? Mary? Okay, 1 and 1, sure. But if 1 goes into 1 one times and 1 goes into 1 one time, so technically they're as simple as they go, we have to have something there. They can never become 0. And here's why. If this becomes 0, everything in the top goes away. And that wouldn't be okay. Because cheese times 0 is 0. A times 0 would be 0. 3 times 0 would be 0. 2 times 0 would be 0. So we cannot make it 0. So the simplest it can become is 1. That is a fantastic point, and I'm glad that you brought that up. Yes, over there, hand in the sky. Yes. The cheese can be gotten rid of. We have cheese in the top and cheese in the bottom. So actually those go away. And we're left with a 1 here and a 1 here. Because cheese goes into cheese one time. Okay? So they literally cancel each other out. And yes, Jaden, what next? The A and the A can cancel. Okay, and we're left with 1 and 1. All right. Yeah, Colby.
What is cheese times 2?
Cheese times 2 is 2 cheese. It's too cheesy for you, sir.
Cheese squared.
Okay. Shh. Now, hey, we're going to take and multiply all the numbers in the top. So you have 2 times 3 times 1 times 1 times 1 over 1 times 1 times 7 times 1 times 1. All right, 2 times 3 is?
I was just thinking, wouldn't that be the same thing as 2 times 3 over 7?
Yeah, but we are going to treat it like this first, okay? But yes, it's the same thing. So it'd be 6 over 7. So the answer to this long, complicated mess is 6/7. Now, this is all you're going to be doing with converting. But instead of cheese, we're going to put things in like miles. Or instead of A, really, come on. There doesn't need to be any noise there.
So it would be like,
Is it really that difficult to think that instead of cheese you could have miles, or instead of A you could have feet? It's the same thing. It's a placeholder. It's just a label. Okay? You're substituting something in. Emma.
so basically the answer is 6/7 cheese.
No, there is no more cheese. We canceled them out. They're gone.
The miles could cancel out and then it could eventually be.
Right. The whole idea is we could cancel units out and get to the unit that we want. Okay? So, you're going to see this play out today. For those of you in my science class, you're going to be familiar with some of this already because half of these notes are a review from 2 units ago. Okay? All right. Here we go. Dimensional analysis, that was just our intro activity. Let's go ahead and look at this. Here are some examples of the kinds of problems that we can solve using this method. Any sort of conversion, so long as we are dealing with units that are compatible. Let me explain what that means. How many centimeters are in 2 miles? Are centimeters and miles compatible? Do they both represent the same type of measurement? Okay. They're both units of what? Length. So they are compatible because they're both units of length. If you have 2 units of length, you can convert between them. How many pounds are in 54 kilograms? These are both units of mass / weight. On Earth, they fulfill similar roles. In other parts of the universe, they do not. On Earth they do. So yes, we could say these are both units of mass / weight, and so they are compatible. How many seconds are in 16 years? Are seconds and years compatible? They are, because they're both units of what? Time, okay? So we can say that they are compatible. Therefore, there is a conversion between seconds and years, okay? Most of the conversion factors you would need to solve these three are on your blue sheet, okay? They're on there. And you can see on the blue sheet that they're actually broken up by their compatibility. So all the length ones are together. All of the mass and weight ones are together. All the volume are together. All the temperature are together. Emma.
To find that first question, wouldn't you just do like, because there's 2.54 centimeters in 1 inch, so you would do 2.54 times 12, and then 12 times.
Yes, Emma. Yeah, we will get there. But yes, that's a 3-step conversion. That's I'm not going to go there quite yet, but yes, that's exactly what you would do. Okay. So let me continue. Let me continue. Unless you have a question about the blue sheet,
Well,
go ahead.
so are we gonna have like this for our homework, like where
Yes.
you convert the
Mm-hmm.
like miles?
But these conversions will not be hard if you have the blue sheet and you understand the process. You'll actually probably be one of the easier homework assignments for you. But you got to understand the process. And I think you will. I really do. Yes.
I don't know if this is part of it, but what number is
Tara?
Not even.
It's huge.
One.
Tara? It's a trillion.
Oh, I know.
Okay. All right. Let me get to that next part. Bo kind of brings us into this next part. Here are the SI base units: length, volume, mass, time, and memory. This is a new one that I have not shown before. Okay. Like, yeah, have you ever heard of a gigabyte? Or a megabyte? Okay, a terabyte. So we have length. Its base unit is the meter. Okay, in the big world that we live in, meters is the predominant unit of length, not feet. That's just here in America. Okay, volume, okay, is the primary or dominant unit for, or it has a prominent primary base unit of liters. Hence the reason we have 2-liter bottles or 3-liter bottles, or most small bottles are not 20 ounces, but you can get the 1-liter bottle. Okay, you have mass. Mass is sort of like weight, it's kind of a bit different, but mass is measured in grams. Okay. Time is always measured in the scientific community and in the big world in general in seconds. And then memory for like computers is measured in bytes, and we can say things like gigabyte and megabyte. All right. Every one of these units, okay, is what we call a base unit. It's a starting point. However, if we want a lot of these units, we add something in front of it to make it bigger, like a kilobyte. A kilobyte is 1,000 bytes. The word kilo means 1,000. All right. Tera means trillion, so terabyte would be 1,000,000,000 bytes. Mega means million, mega millions. So mega literally means you have 1,000,000 bytes. But then you get into the reverse side of things. We have milli and centi. Centi is smaller than 1, so that means 1/100th of a byte, so a centibyte. Okay, or a millibyte. It used to be that things were measured in millibytes. That's a long time ago, it seems like. Millibytes, okay, or milliseconds. That's 1,000th of your base unit, or 1,000th of a second. It kind of changes it a little bit. It's the base unit tells you what you're working with: length, volume, mass, weight, memory, and then you can adjust that number based on what prefix you put in front of it. Yeah, I used to own a cherry red minivan. Okay, it was an awesome minivan. I owned it. It was a caravan. It was fantastic. Oh, because it was just awesome. It was the party wagon, man. And so in college, I had this cherry red minivan, and it had a full stereo system, and I had a microphone hooked up to so we could do karaoke in the van. All right. But the best thing about this van is that the speedometer was not in miles per hour. It was in kilometers per hour.
Oh, you said this on your.
Oh, yeah.
The 8th grade.
Yep, this was in kilometers per hour. So my cherry red minivan did not, or I could not read miles per hour in the van because I had to be able to convert on the fly as I was driving kilometers per hour to miles per hour. So if I was on the highway, my speedometer would read approximately 120 kilometers per hour. Okay.
Sir, how fast are you going?
That-
versus miles per hour.
Sure it is. Most cars nowadays come standard with both. You can actually flip a switch and it switches it over. So if you own a vehicle that's been made in the last 5 or 6 years, the odds are it has the ability to be in kilometers per hour or meters per or miles per hour. Oh yeah, it's fine. So long as I'm not breaking the law, I'm fine. So I just had to know the conversion. See, kilometer is a word that means 1,000 meters. Kilo means 1,000. So a kilometer per hour means that every hour I was going approximately 1,000 meters. That's a kilometer per hour. If I was going 120 kilometers per hour, that means that I was going 120 times 1,000 meters, or 120,000 meters every hour. Okay, so we change the unit slightly using prefixes. Here are some of what those prefixes represent. This might be a pretty helpful slide. I would star it just in case you come across something that is slightly confusing to you. Okay? I would star this slide. These are the ones I would expect you to probably be able to either know or use on to know in your homework.
Except for micro and giga.
Right. Milli, centi, kilo, mega, giga, micro. This means 1 millionth. Mega means million. They both start with M.
Are these all on the blue sheet?
Yes, they are. Milli means 1,000. Giga means 1 million, or 1 billion, excuse me. Kilo is 1,000. Centi is 100th. Okay, notice that your really small units are here, your small prefixes. Your ones that are huge multiples are here. Okay. Notice that the ones with the lowercase letters usually mean that you're making the number smaller, or you're working with a smaller unit. Whereas if you have a capital letter, that typically means that you're working with a unit that is larger than your base unit. Okay? So a lowercase letter means that you're working with something less than your base unit. A capital letter usually means that you're working with something larger than your base unit. So these prefixes are very helpful. You will see them quite a bit in high school. I don't want you going to high school not having seen or being able to understand what they are. So not only do you get a little bit of this in math class, you will get it in science as well. Conversion fractions are basically two things that we compare, like 12 inches, 1 foot, 60 seconds, 1 minute. And we write them as fractions. All right, we write them as fractions. So what you should understand here, 1,000 meters, well, that's the same thing as 1 kilometer. If Bo were to start at point A and go 1,000 meters, or Bo were to start at point A and go 1 kilometer, he'd end up in the same spot. So these are technically the same distance. They just look a little different. Same thing here, 1 gram or 1,000 milligrams. Well, 1 gram and 1,000 milligrams is the same amount of mass. If I measured out 1 gram of substance or 1,000 milligrams of a substance, I'd have the same amount. So you see that sometimes we represent things, the same thing, using different units. I could say, hey, let's go 3 feet. Okay, how else could that be represented? Yeah, I could also say I'm going 1 yard. That's the same distance, but we use a different unit to describe that distance. So conversion fractions, conversion factors, basically conversions are necessary because people describe events, amounts, time differently. Okay? One person on one side of the world might be using meters. Here in America, we might use yards. So there's a lot of converting that has to take place. If we all use the metric system, this probably wouldn't be an issue. We probably wouldn't learn this in school as much, or at least not to the same extent. But America, America having its own set of units and being a world power, therefore means that we have to learn both systems. Because most of the scientific community uses metric, Americans do not, and so when the two come head to head, there has to be a conversion that takes place. So this conversion, or these conversion fractions, help us to see from one side to the other, so that the scientific community is not separated from the general public. They can understand each other. Yes, Colby? How can you use this in real life? Well, if you buy a van from Canada, that's going to be really useful to you. The other thing that might be really useful is you travel a lot. Conversions are also used for currency.
Like you said, if our kids were...
Another instance, let's say you go to a country and you have a child and they get sick. They give you a thermometer. It's going to be in Celsius. So you're going to need to know what that is roughly in Fahrenheit. Okay? So, yeah, there are times and places for conversions. In order to pass high school science, you will need to know conversions inside and out. Okay? You'll need to know them forwards and backwards. All of what you do in high school will be in the metric system. Okay? So you need to learn how to use it. Let's take a look at some conversion fractions. You have two examples here. What I want you to write and add to this slide is that fractions can be written two ways. Not only can you have 1,000 meters, okay, equals over 1 kilometer, but you can also have 1 kilometer over 1,000 meters. It doesn't always matter which way you write it. Because they equal each other, they just look different, they can be written depending on how you need them. Sometimes you will have to use the fraction on the left to solve a problem. Sometimes you will have to use the fraction on the right to solve a problem. And you'll see how this plays out in a minute. Kind of think back to our first example when we were looking at multiplying fractions. These fractions come into play. The same thing is true, whoa, Mr. Bornheimer, over here. 1 gram equals 1,000 milligrams. Well, you could also write this how? Yeah. 1,000 milligrams equals 1 gram. Because I'm writing them as fractions and they have different units, these are proportions. They're ratios. They're rates. This is literally what we were talking about yesterday. I'm making a what? Starts with com and ends with parison. Comparison. Yes, ladies and gentlemen. We are literally making a comparison. These are ratios. They're ratios of grams to milligrams. This is all of what you were doing last night in your homework. Okay? You can basically make a comparison between anything. These are special types of comparisons, though. They're special types of comparisons because the number in the top and or whatever's in the top and whatever's in the bottom actually represent the same thing. They just look different. Like 12 inches equals 1 foot. If I measure out 12 inches and I measure out 1 foot, I'm going to get the same. Same distance, same length. That's what makes conversion factors unique. The number in the top and the units in the top, the numbers in the bottom and the units in the bottom actually represent the same distance or the same volume or the same mass or the same time. Okay? Could you think of a way you could write a comparison between seconds and minutes. Okay? Think of a way you could write a comparison between seconds and minutes. Right now in your notes, come up with two fractions, just like this, where you could compare seconds and minutes. Okay? Think of a way that you could compare. So you kind of want to be thinking in your head, they have to be really representing the same amount of time. Kind of like 60 minutes equals 1 hour. That's the same amount of time. If 60 minutes goes by, that's literally an hour that went by. We just use a different unit to describe it. Okay, so I'm going to come around and take a look. Yeah. Okay. Yeah. I've seen some good stuff. Yes. Yep. You're writing two fractions to represent the relationship between seconds and minutes. Yes. It should be very similar to this. One should be this way and one should be flipped. Yeah. Mm-hmm. It should look something like this. This would be a really good example of this. You could have 60 seconds over 1 minute. Those two are the same amount of time represented. This is the proportion between seconds and minutes. Or you could also write it as 1 minute over 60 seconds. Take a look on your paper at the section on length. Okay, take a look at your blue sheet. You see 3 feet and 1 yard? You would write that like this. You would write that as 3 feet over 1 yard, or what? 1 yard over 3 feet. Every conversion factor on your blue sheet can be written as 2 fractions. Okay, I would write that down in the margin for this slide. Every conversion factor, every conversion on your blue sheet can be written as 2 fractions. Can be written as 2 fractions. Okay. Last but not least, we're going to get through one example today, and then you're going to have 3 to try at home tonight. That's your only homework, is to try 3. Tomorrow you'll have a more normal homework assignment, but tonight I want you just to try the process. Yes, Gloria. Oh, don't pack up yet. We're not done. Oh, good man, good man. Okay. They might ask you metric to standard or standard to metric. It just depends on what you're going for. Oftentimes, if they do give you something, it'll be centimeters to something. Okay. All right. When you are given a problem like how many feet are in 25 miles, the first and very first thing you do is you write down the number and the unit given to you in the problem. So the very first thing I do is I identify, okay, this is on the next one, that they give me this term right here, 25 miles. I start by writing that down. As soon as I've done that, I draw my crossbars, okay, to set it up like this. And I only do one to begin with. Okay. The next thing I do is I address, or I figure out what it is I'm trying to convert to. Austin, could you tell me, based on this one statement, how many feet are in 25 miles? What am I trying to find? What am I trying to convert to? From miles to feet. So the next thing I do, ladies and gentlemen, is I write feet over here, and that is my goal. That is what I'm trying to convert to. So I go to my conversion sheet, my blue sheet, and I say, is there any conversion that's already made for me between miles and feet? Yes. Okay, there is. Emma, could you say it? 5,280 feet. Okay, 5,280 feet equals 1 mile. Okay, that is the conversion. I can write it as 2 what? 2 what? I can write the same conversion in different format. I can write it 2 ways. 2 what? Yeah, Mary? Yep. You can write it as 2 fractions. And I always start by, when you're learning this for the first time, you should always write both fractions. You're only going to use one of them. Oh, that's a great question. If they're the same thing, why does it matter? It matters because we want to make sure, or we want to cancel out miles. We want miles to go away. Because what do I want to end up with only? One number, and which unit? Feet. So I want what unit to go away? Miles. So if miles starts in the numerator, then I got to put miles in the denominator on the next one so that they can cancel out. So which fraction am I going to use? Am I going to use the one on the left or the one on the right? Yeah, Erica. The one on the left. Okay? I'm going to use this one right here. And I'm basically literally going to substitute that up into that cavity right there. So I'm going to go ahead and I'm going to put it in there. 5,280 feet over 1 mile. Or I will say 1 miles. Okay? Now, because I have miles in the top and miles in the bottom, what happens to them? They cancel out. Not the numbers, just the units. Think of miles as like that hunk of cheese, or the A, or X, or Y. It's just a placeholder. The miles goes away, and I'm left with two fractions I can multiply. If there's nothing in the space under the first one, you can literally put a 1 in there. Okay, just like if you have a 9, that's really the same thing as 9 over 1. Or if you have 10, it's the same thing as 10 over 1. So this one is 25 over 1 times 5,280 feet over 1. And so you end up with the following as your math. 5,280. Let me move my goal over a little bit. Feet times 25 all over 1. And what is that going to equal, Grace?
130.
And the answer is 132,000 feet, because that's the only unit I have left that I have not canceled. Yep, 132,000 is those two numbers multiplied by each other. Do you get this, ladies and gentlemen? Does it kind of make sense?
Yeah, 75%.
Okay, you need to try it tonight. So, what you need to do is you need to finish all of the conversions up through page 4.